All right, in this video, I just want to repeat the steps we did in the classes about how to generate the confidence intervals and how to compute a hypothesis test based on the dataset or the summary statistics. All right, so first, use our example here. Right, so we have this dataset, right? This is a sample with all detailed values in for each observation, right? And then first we want to generate a confidence interval for the stopping distance, right? So that means we need to analyze distribution, and then we want to make a distribution about this variable stopping distance, right? And then click OK. Right, and then this is the default output, so I want to change the direction, right? So we click this red triangle and then choose stack, right? So that's this output will be changed the direction, right? So in the default output, we have the summary statistics table, and first one will be the mean of this sample, so it will be the sample mean x bar, and then standard deviation, which is the sample standard deviation, and you have the default confidence interval, which is 95% confidence interval. You have the lower level, you have the upper level. All right, and then what if I don't want the 95% confidence interval? What if I want a 90%, 99%, or other percentage of the confidence interval? Then you choose the red triangle beside this variable's name, right? Red triangle, and then you have all of these options, and then in these options we have the confidence interval. All right, and then choose other. So the first thing you need to enter is what will be your confidence level, right? So in this case, for example, I want a 90% confidence interval. Then I just change this to 0.90. All right, and then I want the two-sided confidence interval, both upper level and lower level, right? And in this case, I don't know the sigma, which is the population standard deviation. So we will uncheck this box and then say OK. All right, and then you will have a confidence interval in your original output, right? Just beside your summary statistics, you have a 90% confidence interval for the mean. So your confidence interval will be from 56.76 to 59.03. All right, next, what if I know the population standard deviation, sigma? Then we say confidence interval, others. Remember, we have this option, right? Use the known sigma, right? Click OK. So if, for example, if I know the population standard deviation sigma as 6, and then just enter 6 and then click OK, and then you will have another confidence interval. In this case, you have one more column. It will show you what is the value of the population standard deviation sigma. This is the value we entered, right? And then you will have another confidence interval. So this confidence interval is based on the Z star, not the T star. Right, so this is based on the T star because the population standard deviation sigma is not given. All right, so this is about the confidence interval with a given raw data. Right, what if I don't know the what if I don't know the detailed values in this sample? What I know is sample statistics. Then you just click help, right, and then choose sample data, right, and then in this screen you have many functions. Choose the calculators here, right, and then you have the options for confidence interval for one mean or the confidence interval for one proportion, right? So just for example, we use the confidence interval for one mean. Then we say to enter these blanks, you need to figure out you have a z confidence interval or a t confidence interval depending on whether you have the population standard deviation sigma, right? All right, so let's just use our example for details, right? So in the chapter note example 2, we calculate the confidence interval for the mean cholesterol levels, right? So in this case, do we have the population standard deviation? Actually, we have, right? So that means we need to use the z star, right? We have the z confidence interval. Then we just enter the sample average, which is 200. Right? The population standard deviation is 30, and then the sample size we have is 42, right? And then we want, actually in this, we have the sample mean, which is 200, right? And then we have the population standard deviation is given, which is 30. And then the sample size is 42, so just enter 42 here. And then the confidence level, we want to produce a 99% confidence interval, right? So here we need to enter 0.99 and then enter. Then you will have a confidence interval, which is from 188.08 to 211.92, which is exactly the same with our calculations, right? And also in the class, we also talked about what if this 30 is not a population standard deviation? What if this 30 is the sample standard deviation? That means the population standard deviation is not given. Then you need to use t, right? And then you need to enter 30 as the sample standard deviation. And then if nothing else changed, right? So your confidence interval will be from 187.496, which is 187.5 to 212.5, right? Exactly the same with our calculations. All right, so this will be about the confidence interval. And then next, I want to talk about the steps for the hypothesis test. Right, so again, let's just use the same data set, right? We say we want to test about whether the population mean stopping distance is less than 60, right? Then how I can do the hypothesis test? Again, analyze distribution, and I want to analyze this variable, pull it to the y, and then click OK. And then again, change the direction by stacking it. All right, and then I want to make a hypothesis test about the population mean, right? So we are testing about the mean, test the mean. All right, and then I want to test about whether the population mean is less than 60 or less than 60 or not, right? So it will be our hypothesized mean will be 60. And then here, if you have the population standard deviation given to you, then you can enter it here. Otherwise, if you don't have the population standard deviation, just keep it blank, right? So let's try both cases. If I don't know the population standard deviation, then I will have the t-test, right? That means this test statistics is a t-test statistics, and then you have the p-value for the two-tail hypothesis, right-tail hypothesis, and left-tail hypothesis, right? So in our case, we want to test whether the population mean is less than 60, so it will be left probability, left p-value, right? So this will be this 0.0014 will be the p-value for our hypothesis test, right? So next, what if I know the population standard deviation? I still want to test about 60, but now the population standard deviation, let's say 6. All right, and then click OK. Now you have another hypothesis test about 60, but now the sigma is given as 6. That's the value we entered, right? And then we have a z-test statistics because what? Because the sigma is given, right? So you have the two-tail p-value, right-tail p-value, and left-tail p-value. All right, so that will be about the hypothesis test based on a detailed data set, right? So again, what if I don't know the detailed observations in my sample? What if I know only the X bar, only know the sample size? Then again, go to help, sample data, all right, and then go to the calculators, and then where you find the confidence interval, the next ones will be the hypothesis test, right? So let's still use our example in the chapter note, right? All right, so in our example here, right, we want to test about whether the mu is larger than 12,000 miles, right? Then we just come to the calculators. We want to test about the mean, right? We don't have the raw data, we have the summary statistics. Click OK. All right, and then here you still need to choose the type of test first, right? So in this case, we know the population standard deviation is not given, right? So we have the t-test statistics. And we want to test whether the mu is larger than 12,000 miles. So that will be the right tail hypothesis, right? Alternative hypothesis will be greater than the hypothesized value of mean, right? And then we need to enter the values. The hypothesized mean will be this 12,000, right? And next, the sample average, which is our sample mean, which is given as 12375, right? And then next, sample standard deviation. The sample standard deviation is S, which is 2415. And next, sample size is 225. Significance level, let's set as 0.05, all right, and then enter. All right, then you will have the test results. You have first the standard error of the mean, which is the bottom part of the t-test statistics formula, right? And then next, t-score is actually your t-test statistics, right, which is 2.33, exactly the same with our results, right? And then the last one is the p-value. So p-value, you have the exact p-value, not the range of the p-value anymore, because we are not using the t-table. We have the jump to give the exact p-value, which is 0.0104. The consistent result in our when we do by hand, right? So we say the p-value is between 0.01 and 0.025. So exact p-value is 0.0104. And if you check this box, it will tell you that based on this alpha, based on this 0.05 alpha and this p-value, you should reject the null hypothesis because your p-value is less than the alpha. All right, so that will be all about the jump steps.